First of all, for the Sherlock Holmes fans amongst you, I've just got to get this out of the way to start off with. Yes, it's Professor Moriarty, but it's physics, not mathematics, and I've never been such a fan of the binomial theorem, for those of you who are familiar with Holmes's archenemy. So I am not actually going to talk directly about impact, though that is a particular bugbear of mine. What I'm going to talk about, well, as you can see, it's up there. I'm always keen on a bit of alliteration. About peer review and public, so where peer review is going in terms of what's now called post-publication peer review. When you think about it, you step back and think about it, it's really archaic the way traditional peer review works in this day and age. In that, in physics, you submit your paper, you get back one referee's comment, one set, 2, 3, maybe 4, and then if it goes out to another set of reviewers, you might end up with 5 or 6. Anonymous, you get those comments back, you revise your paper, it gets accepted in that journal or it doesn't, and you send it off somewhere else and it goes through the whole process again. But the problem is that we see the paper, the publication, particularly if it's in one of those top-tier journals, and I'll spend quite a bit of time talking about those top-tier journals. We see that as the end of the process rather than the beginning. The publication should be the start of the debate. The reviewing should happen, the criticism of the results should not happen behind closed doors before the paper's published. The paper should be published, and that should be the start of the scientific debate. Because, you know, the idea that the paper's published and that's the last word is just complete anathema to science. So I'm going to tell you, in terms of the evolution of peer review and how we've got embroiled in a number of debates online. In particular, something called PubPeer. Can I have a show of hands? I always ask this question. It's a different audience for me. How many of you have heard of PubPeer? Interesting. Mark. Nobody else. Okay, so PubPeer is a post-publication peer review site, very important site, getting increasing visibility, but not quite fast enough. So I'll talk about that in quite some detail. Okay, so my day job is just a few words on this. I'm a condensed matter physicist, physical chemist, chemical physicist, nanoscientist, surface scientist, whatever those terms you want to use. What we do is we focus on imaging single atoms, single molecules, single bonds, manipulating matter right at the atomic level. The way I like to couch this in terms of public talks, more general talks, is can we do 3D printing with atoms? Can we set up a computer to build a particle or to build a structure atom by atom? And we do this work in pretty extreme environments. These are ultra-high vacuum systems, lots of stainless steel. The vacuum inside there is comparable to that you get in deep space and at very low temperatures, 5 degrees above absolute zero. And what you're seeing in the video is an image of each one of those blobs is a single atom. And we're moving those atoms around at the atomic and indeed, in the sense, in terms of the precision, at the subatomic level. We've got better resolution than an atom. I put that up there just to show you that, you know, I'm not in the biomedical regime. In terms of ethical concerns, we work with inorganic silicon and, you know, metal surfaces. The ethics that concern me are not the ethics, as was raised a number of times, in terms of, you know, human involvement in experiments or whatever. The ethics are more about the publication process and the peer review process. And that's, as you know, that's what I'm going to focus on. By the way, interrupt me at any point, stick your hand up, shout at me, throw something at me, just get my attention if you've got a question. So I spoke, as I say, this is a pretty different gig for me, but I spoke also at a conference called the World Conference on Research Integrity back in July. And there were 2 people who spoke at that conference. Some of you might have even been there, Lex Bruter and Brian Martinson. And there were a couple of things they said which were really, really interesting to me. Sloppy science is a larger evil than research misconduct. So I'm going to tell you about a case where it's not so much that we're embroiled in, or have been embroiled in, and thankfully it's coming to an end, where it's not so much a case of there was direct fraudulent manipulation of data, at least to the best of our knowledge. It's a case that the work was really sloppy, really, really sloppy. Work that you would not, or certainly I would not, and my colleagues would not, let through, not even as a master's project, but not as an undergraduate project, or indeed not as an undergraduate lab report. It was so flawed, yet published in those top-tier journals. And this it really brought, I'd always had concerns about this, but it really brought home to me how dangerous it is in terms of using the name of a journal as a proxy for quality. And that's what we do all the time. I'm sure in your field, I'm not entirely certain what you would consider those top-tier journals or those top-tier publications, but I have sat in quite a number of committees looking at CVs from researchers, and sitting around a table, somebody's sitting opposite me, we're considering candidate X and candidate Y, and go, well, candidate X has got much better publications than candidate Y. How do you know? Have you read them? No, you haven't read them. You've gone, candidate X, oh, they've published in Science, Nature, Cell, or whatever, for us physical review letters. Candidate Y hasn't. So you've outsourced your quality assessment to the brand of the journal, to the name of the journal. That's exceptionally dangerous, and I'll give you a number of reasons why that is the case. So the sloppy science is a large evil and research misconduct. I'll certainly be touching on that. And this large underestimation of the importance of fear. What does Brian mean by that? Well, what drives that fraudulent work? What drives the sloppiness? What drives the need to must get this paper through to these top-tier journals? Otherwise, what's going to happen to my career? That's what's underpinning an awful lot of this. Must get published in those journals, because if I don't get published in those journals, if it's not newsworthy enough to be published in those journals, and newsworthy means must get rid of any uncertainty, it's got to be a very powerful message. So if I can't get that through, if I can't get that message through by cutting away any of the perhaps uncertainty, then what's going to happen to my career? And I'll put this in the context of physics. I've mentioned this to a few of you before, but it's a very important letter. It was published in, it says last month's Physics World. It was actually published back in June. So this is an ex-head of department at Imperial College, physics, and he basically did the numbers. On average, 36 appointments will be made annually to postdocs in the UK, so this is permanent positions, or 1.7% annually of the postdoc population can expect to get a permanent position. And what makes a difference in terms of getting a permanent position? Okay, outreach is good, some evidence of teaching is good, but right at the top of the list, orders of magnitude up the scale from those are, what journals have you published in? Have you published in Science? Have you published in Nature? And that fear, that intense competition drives a lot of the problems. And, even if you're not going to publish in those, so you're not aiming for those top-tier journals, publications are very important. This is from, when was it, last year at some point? Yeah, so around about February last year. This was from a set of conference proceedings, and the publishers had to turn away more than 120 gibberish papers because they were computer-generated. So they were sent in, completely computer-generated, accepted. There was a fantastic meme, I searched for it, I couldn't find it this morning, I don't know why. Fantastic meme where a guy continually get badgered, as we all do, by these rather disingenuous conferences where they say, please submit your paper, please submit. And you try to take them off the subscription list, you try to get off there, you send them lots and lots of emails, they never take you off, you keep getting them these messages. So what this guy was sent them back, what did was he just set up a paper, which was, and excuse the language, the title of the paper was, take me off your fucking email list, and then unsubscribe me, please fucking unsubscribe me. That was the entire content of the paper, and then there was a little figure which was unsubscribe me, unsubscribe me, unsubscribe, take me off your mailing list. Sent it off and it was accepted. So, there's an awful lot of very dodgy practice out there. This, in my field, is a real eye-opener. So this was a paper published in a journal called Nano Letters. So for the nanoscience community, the community interested in very small things, atoms, molecules, etc., nano is sort of our cell. It's at that level. It's not quite, many would consider, not quite the nature science level, but the next tier down. Very prestigious journal from a very prestigious organization, American Chemical Society. And so this really struck a nerve with me, resonated with me, because we've done a lot of work in nanoparticles and how they organize in surfaces. So what this experiment is doing, it's pretty easy to explain. So you take gold nanorods. So each one of those little things is a gold nanorod, which is about 50 nanometers, very, very small in length, and as you can see, about 10 nanometers or so across. And you have them dissolved in a solution. And you put that solution on a surface, and you let it dry. And it's very interesting. I could bore your senses of very interesting parallels between that process and if you have coffee and it dries on a surface, the staining you get. It's very interesting. But, so they organize. And generally when you do that, you get a bit of a mess because they go down randomly. And it's difficult to control them. You can do things. You can play with the surface chemistry. You can play with the chemistry of the particles. You can get them to try and organize. And indeed, it's like a little playground for nonlinear physics. Lots of really interesting stuff. This was astounding. And that's why it ended up in that journal is, wow, what? Why the heck did they do that? What's happening? And there's no bonding. They hadn't, apparently done anything with the linkages to get that. This was like a random, sort of, you just drop it on the surface and it disappears. And you look at that and you go, as a reviewer, you would go, that's really interesting. What the heck is going on at the vertices there? What's causing that? And as you can see, they were called, I think it's up there, nano chopsticks, because you've got to have nano. There's everything from nano cabbages to nanoputians, which was the best one, little miniature nanoscale men, which I thought was great. But you just need that nano tag. But so here's what you do if you zoom in. And this was actually in the supplementary information. Now, some of the eagle-eyed among you might have spotted it already. Can you see the problem? Right? So just let me ring. Can you see that? They'd cut and pasted. They'd taken these, cut and pasted in them, and rearranged them. Right? My 10-year-old daughter, she's now 12, but my 10-year-old daughter at the time said, Daddy, why didn't they use the lasso tool? Now, that's either immense arrogance or immense stupidity, or a combination of both. That is remarkable. But what's worse, no, not worse, what's equally bad is that the reviewers didn't spot it. That this went through. Something as glaringly, obviously bad as that went through review process for one of the most prestigious journals in nanoscience. Straight through. So, and the really worrying thing is this. If they had used the lasso tool, we probably wouldn't have spotted it. And then you will have lots of researchers across the world applying for grants, or already taking students and postdocs that are on other projects. Oh, look at this, maybe we can exploit this, and maybe if we think about this and how we can arrange these, then we can have nice little, optical traps, etc., etc. We can think about these as little switches. We can do a whole range of things. You could see how that vast research effort would start off if they'd done it right. If they'd spent 10 minutes more to do it right, to get the fraud right. How much wasted time, effort, and money would that be? Luckily, in this case, this was retracted pretty quickly, but only because blogs picked it up. If this had to go through the normal process, this was Chembark, this is and another blog picked up on this very rapidly. Without this type of pressure via social media, this would have stayed in the literature for a long, long time. Because what's the traditional process? Send letter to editor. Letter goes out to authors of paper. Authors of paper go, oh shit, we really need to try and sort of keep this under wraps as much as possible. How are we going to try and block this process? And it goes on, and it goes on, and it goes on, and maybe 2 or 3 years down the line something comes out. And that's much too late. It's just archaic. We've got effectively instantaneous communication. It's just archaic to think that we have to do the process that way. How many of you are familiar with the Heinrich Schon case? Just show of hands. Nobody. Okay. So Heinrich Schon was, this for my field, was a really, really bad case. This got a lot of attention. It's about 10 years old now. Again, in the same sort of nanoscience field, but in this case in molecular electronics. So he was working, this guy, Schon, was basically tipped for a Nobel Prize. And it was just remarkable. He did a whole series of experiments and analyses related to using single molecules as electronic devices. Really tricky experiments that nobody else could reproduce. And he was publishing, and this should have been a major klaxon, he was publishing at the rate at one point of a paper every 10 days. You just cannot do the experiments that quickly. And not in crap journals. Science, Nature, the top class journals. And he was not a person to not use the lasso tool, let's put it that way. He was extremely careful and extremely clever, and the way he wrote up his papers, it was more work to do the fraud than to actually do the experiments, because he was so careful, and he made sure that his experimental results, in inverted commas, matched up with what the theorists would really like to see, and also matched up with the general intuition of physicists in terms of, yeah, maybe if we change this, we put a higher magnetic field on that, you'd expect that to open up, you'd expect that peak to shift, etc. Very clever, very subtle. But the way he was found out was, in the end, he really badly slipped up, in that he submitted 2 papers with exactly the same data, down to the noise, down to the random noise. He said they were from two completely different devices, 2 completely different molecules, yet down to the random wiggles, which have to be different from sample to sample, they were exactly the same. And so that's when it started to unravel, and people started to go back through his papers. I had one colleague who spent a lot of time with a photocopier. This, even though it was 10 years ago, he's fairly old school. Copying onto slides, onto transparencies, and then holding up, and he'd periodically come out of his office, go, look, I've got another one, I've got another one. So it just started to unravel, but very clever fraud. And this is why that statement, okay, no, I'll focus on something else for the time before I come back to that. So, this is, I mentioned that we were embroiled in a debate. Now, I realize I am not the most disinterested of observers or participants here, so I don't want to go spend a lot of time slagging off the competition or slagging off the other side of our opponents, but it's a pretty simple idea, actually. So the idea is you take a nanoparticle and you coat it with 2 different types of molecules. And those molecules apparently phase separate, and there's the lovely cartoon, science by PowerPoint or science by graphic art, lovely demonstration. They form stripes. And why is that important? Why should you give a damn about that? Well, from a range of different perspectives. If you coat the particles with those type of stripes, they interact in a different way. And that's important if you want to build electronic devices where you want to have charge flow from particle to particle. More importantly, and this is really where it gets a little bit worrying, is that the argument is that these particles with this type of coating stand a better chance of getting into cells, okay, and could be used for drug delivery and that type of thing. Once you're now starting to focus on the biomedical side, it becomes a little bit more troublesome in terms of the ethics of what's going on here. And so the key piece of data supporting this, and this was published in Nature Materials, is this image on the left. And certainly it looks like stripes. It looks like stripes. But you show that image is taken with something called a scanning probe microscope, which is our stock in trade. So a scanning probe microscope is a microscope like no other. You don't have any lenses, mirrors, optics at all. Some of you may be familiar with the quantum corral and the IBM logo spelt out in atoms. Have you seen this? Where you've got the corral and you can see the way those were formed was using the scanning probe microscope. So in a nutshell, sharp probe, bring it in close to a surface, and when I say close, within a few atomic diameters, move it back and forth, measure some force or some current, and build up an image that way. And if the probe is substantially sharper than this, atomically sharp, then you can see individual atoms. Or, in this case, you can argue that you can see individual molecules. So you move it across the particle, and the idea here is those stripes you're seeing are the stripes in the particle. However, the way the microscope works, without getting into too many technical details, is that you need to be able to control this position very precisely. So there's a feedback loop, which detects the signal and then adjusts the position of the probe accordingly. Like any feedback loop, like any system, if you wind up the gains on a feedback loop, this thing becomes very sensitive and it starts to oscillate. This is scanning probe microscopy 101. This is what we tell the students on day 1 when they come in, undergraduates, postgraduates, postdocs who are from an unfamiliar technique. Avoid this. Keep your gains low, because if you don't keep the gains low, you can generate whatever artifacts you like. And here's how you check if your gains are low. Point 1, point 2, point 3. Scanning probe microscopy 101. And yet this got past peer review, not just once or twice, 30 times. A train of papers, 30 papers based on an appallingly fundamental artifact. Appallingly bad. And that, you know, you can take my word for it. We went and published a paper which looks at all those different types of artifacts. There's not just this one, there's a whole range. And you're very welcome to look at that and, you know, quibble with the details, but ultimately that's the problem. And then, leaving aside the technical issues, it gets very interesting in terms of the sociology. So how did this artifact persist? How did it end up getting into 30 papers? And again, not in crap journals. Well, somehow, remarkably, the referees yet again are asleep on the job for this paper, and it gets into Nature Materials. Now, you can guarantee when the next paper is submitted, first thing is that the referees go, oh, they published in Nature Materials. Must be a fairly good group. Fairly good group. That means this must be pretty quality work. And your bar drops. The bar drops, and that gets published. And then it comes to the next one. Oh, they've published in Nature Materials and Science. Oh, and JACS, which is a wonderful acronym for Journal of the American Chemical Society. They must be a quality group. And it builds, and it builds, and it builds. All a house of cards built on an artifact. And why does it work so well? This. What you need is a good, compelling story. And this came along, it might seem like a little niche, a storm in a sort of nano teacup, but it's not. It came along at the right time. People were very interested, can we get nanoparticles into cells, and what do we have to do to change them? And this was a very compelling story based around nice, simple graphics. Just like a journalist, story is very compelling, and the headline, the newsworthiness trumps the rigor. For scientists, you ask any scientist, if you want to get published in Nature and Science, what's the key hurdle? Is it the peer review process? No, it's not the peer review process. It's getting past the editor. The editor, who is not an expert in the field, sifts out 80 to 90% of the papers on the basis of newsworthiness. Is this exciting enough? So it's not the rigor of your science. Often, it's is it going to generate headlines? Will this end up on the BBC website? Is CNN going to publish this? This is not to say, I don't want to overstate the case too much, that there isn't fantastic, brilliant work published in Nature and Science. Of course there are groundbreaking papers. However, there are groundbreaking papers published in a range of other journals. As I say, interrupt me, if only to give me a break from the ranting. So Randy Shechtman, Nobel Prize winner a couple of years back, he decided he was going to boycott top science journals for exactly this reason, in terms of newsworthiness trumping rigor. Now, I would love to say that I'm going to do exactly what Shechtman did, but I'm a hypocrite. Because I can't do that. Because I may as well, if I say to the postdocs and students in the group, we're not going to target those journals anymore, we're not even going to aim for them, we're not going to aim to publish in those, I may as well say, forget about your career, just leave now. Because if we're not going to aim for those journals, I've told you about the level of competition, then I just shoot them in the foot. And that's a really irritating place to be in. You'd love to be able to try and do something. It's exactly what we heard yesterday about playing the game. It's extremely frustrating. But there are ways you can subvert the system, you can change the system in a little way. This is really interesting. You see the Nature Materials cover. Look at how powerful that is. Look at just that image alone sells the story so well. And it's an artifact. Many of you familiar with this one? How eating chocolate can help weight loss? No, so this was around about June, July time this year as well. A guy called John Buchanan, who also published in Science year before last, expose of open access journals. I have a lot of time for open access. There are some issues in terms of the quality of some of those journals, but this was a very interesting paper where here the research isn't, in inverted commas, faulty. The research is actually correct at some level. So what they argue is that if you're on a low-carb diet and you eat a chocolate bar every day, you see a reduction in your weight much faster than if you don't eat the chocolate. Right? So picked up, there's the Daily Mail. For those of you who are from England, you know just how rigorous and on the ball the Daily Mail reporting is, and just how carefully they think about all these issues. But The important thing with Bohannon's study was that it was technically a good study, in that it was in line with the way that data and statistics are treated in the field. I'm not going to bore you with the details of the stats, don't worry. But basically what they did was they very cleverly set up the design so that they had very small samples. And then you just look for statistical outliers. And you p-hack, if any of you know what p-values are, you hack the p-values to get the result you want. So you start off with, instead of testing your hypothesis, it's like, this is the hypothesis we want, this is what we want to show, how do we do it? And so, yeah, the Daily Mail picked up on it. The Express, as you might expect, not exactly another quality publication. Very disappointed to see the Irish Examiner, which is slightly higher quality, also picked up on it. Scientists say eating chocolate can help you lose weight. But this is a great example of newsworthiness overcoming rigor. And particularly, if these authors, are attacked on this, he admitted it a week after it was published, they can just go, oh, but hang on, we did everything fine. This is standard practice in the field. It may well be standard practice in the field, but it's nonsense. So, that brings us on to, right, if this stuff is, and this was one of Bohannon's points, and it's a really good one. So if this is nonsense, and it's a really poor study, and the authors admit to it, can they get it retracted? And given that the author himself says the study is meaningless, clearly the journal will retract it. Yes, not necessarily given what we've seen in the past. Absolutely the case. Some people have really struggled to get their own papers where they admit, look, we made an error in calibration, we made an error, to get that retracted. Why? Because it affects the brand of the journal, it affects the perceived quality of the journal. So, in the that long debate about the bloody stripy nanoparticles, we contacted a number of the journals, actually all of the journals, I think, that had published stripy nanoparticle papers. Say, look, we've reanalyzed this, got compelling evidence to show that it's an artifact for these reasons, and here's one of the messages. I've redacted the name of the journal. It's not, first of all, I'll point out it's not a Nature Publishing Group journal. It's not the American Association for the Advancement of Science, so it's not science. But it's a very, very prestigious journal. Thank you for your note and inquiry. However, our journal does not, note the capitalization, publish papers that rely only on existing published data. In other words, we do not publish papers that correct, correlate, just reading it again, reinterpret or in any way use existing published literature data. We only publish papers with original experimental data. Hence, I regret, but we would not be able to consider or publish the manuscript you described. In other words, we don't do science. What is science? It's organized skepticism. It's organized critique. We do not do science. What we're more concerned about is the newsworthiness, not the rigor. Deeply frustrating email. I had to go away and have lots of coffees after that one. Okay, so my colleague who we've been working with on the stripy nanoparticle thing, it wasn't us that started the entire thing. He's been working on it for quite some time. He saw those images initially. He went, oh, that looks really iffy, went back. And what also came out during this process is that the PhD student, one of the PhD students, this was a brave PhD student, who'd been tasked to look at these stripes forming on other types of particles, did exactly what I'd hope any student would do and did some control experiments. Let's take some particles without any functional groups and without any molecules on them. Indeed, let's take some surfaces without any particles. Lo and behold, stripes. And that student was edged out of the group, had to find a new PhD supervisor, lots and lots of really irritating stuff happening. So this was 3 years. In the original critique, we went with clause 1, because all those other journals rejected us in terms of it's not original data, blah-de-blah-de-blah. Clause 1 published it, but before that, my colleague Raphael Levy in Liverpool had spent, as you can see, 3 years to get his criticism through. And all the time, it's building up in the background. More papers are being published. More and more groups are working on this. And I should point out, those papers are not just getting like 1 or 2 citations. We're talking thousands of citations. Lots of groups picking up on this. Let's get off stripy nanoparticles for a second. So this is PubPeer, as I mentioned before. If you don't know what PubPeer is, go and visit PubPeer. It's a site whereby any paper with a DOI, with a digital object identifier, you can submit a critique of. And it's picked up a lot of criticism, but it's also been, which I'll get to in a little while, but it's also been exceptionally important in a number of cases, particularly early last year. Some of you might remember the furore about stem cells. There were the particular stems, if you took normal cells and really hammered them, treated them very badly in terms of acids, you could convert normal cells to stem cells. That was the claim. Published a couple of papers back to back in Nature. Again, not picked up by the referees, but within a week on PubPeer, peers were saying, hang on, there's something really iffy about this. And that led to a couple of groups, one by a guy called Paul Conrad in particular, said, okay, well, let's do citizen science. Let's really think about reproducibility here. And what they did was they got 8 or 9 labs across the world to submit the results. Do this, try and repeat this, and nobody could repeat it. And it unraveled and unraveled and unraveled, and turns out that the results were pretty well made up again. But again, if that had to go through the normal letter to editor, response from authors, etc., it wouldn't have taken years, literally years to get through. So again, our paper had the dubious honor in terms of this critical assessment of the striped nanoparticle stuff of being the most commented paper in PubPeer for a while. That really is a dubious honor. But what was very interesting in terms of the commentary here, 2 things I want to pick up on. And one of the reasons PubPeer's got slated, anonymity. I am a massive hater, if that's too strong a word. That's possibly too strong a word. I strongly dislike online anonymity, particularly when it comes to science. It's really not the way to go, and for reasons I'll explain. But you can see this Peer 1 thing, at least with the Peer 1 handle. What's happened there is that person is registered with the site, so the site know who they are. But you can also offer unregistered submissions. And the problem with an unregistered submission, well, we'll get to that. The problem with unregistered submissions is the following. So we got accused, because we got so frustrated with not getting any traction with the journals. We blogged about this. We said, here are the issues. You know, we tweeted about it. We said there were problems with this and this. And I understand entirely how, if you're on the receiving end of that, it can feel very, very uncomfortable. And nobody wants to see their work attacked. And for scientists, and for all of us, your work is part of you. So an attack on your work, as much as you'd like to be objective and stand back from this, you know it's an attack on you. You will feel it as an attack on you. And this guy, the person whose work we were really challenging, didn't like this and accused us of being effectively cyber-bullies. Made some, that would be not graceful of me. But made a number of comments. This was picked up, as you can see, by the sort of Twitterati, and this was actually before I was on Twitter. And you can see, wow, scientist likens the post-publication peer review comments on his paper to cyberbullying. Right. If you're publicly funded and you're putting your work out in the public domain and you're getting lots and lots of taxpayers' funding, I'm afraid your paper is open for public criticism on whatever public social media forum there is. For me, there's no question about that. This was a huge amount of taxpayers' money. If we cannot publicly criticize publicly funded work, we're in a bad place. But one place I do agree with him is the irritation of anonymity. So there's again another article in Science. This was, I can't remember, a couple of years back. The web's faceless judges, in terms of you get lots and lots of people, and you know what it's like online, who are very willing to slag off others under cover of pseudonyms and under cover of anonymity. It's just gutless, spineless behavior, particularly for scientists. And so, yeah, the idea that, you get these, fearless searchers for the truth, wielding the universal sword of justice, who do it behind a pseudonym, viciously tapping away on their keyboards. I've never been impressed. And as I say, particularly for science, that's a really bad place to go. Moreover, and this is the real irritation, we had a couple of cases of direct identity theft in this, where we had, first of all, there's the possibility of sock puppetry, hence the sock puppets. If it's unregistered and if they're pseudonyms, you can set up as many accounts as you like and you can flood a discussion to make it look like there's an actual debate there when in fact there isn't. Or worse, if you have to register, what can happen is that people can steal identities, and that's exactly what happened in this case. It got really nasty towards the end. Thankfully, it's sort of moved away. I don't know if many of you, I hadn't heard of this technique until a colleague in the States, interestingly enough, anonymously let me know that there's something called the Gish Gallop, which is a creationist debating technique where you just pick up very minor, bitty things and you just completely hammer on those. And so you address them, which we did, and then they come back and they give you exactly the same points, and it's called a Gish Gallop because you end up going around in circles. And particularly if you've got the facility, 5 minutes, brilliant. If you particularly got the facility just to do it under cover of anonymity, you can make that Gish Gallop look as if there's loads of them. So, not a fan of anonymity. Okay, that's enough whining. Regardless of whether it's faulty or fraudulent, how might we try to fix things? I thought this was really good. My first fraud kit, performed decades of scientific fraud. So that it's unfortunately a bit of an unwieldy URL. I'll make these available online because it's really quite nice. Okay, we have a quality paper now, excerpt from a quality paper. Well, it used to be quite quality. So one of the issues here, of course, is the publishing industry. And I know from my interactions with my colleagues in the social sciences at Nottingham and elsewhere, there's an interesting difference of opinion at some level between the sort of more arts and humanities, where book publishing and publishers are not seen to be quite the evil they are for many scientists. And I'm not saying they're always an evil. For example, I work quite closely with the Institute of Physics and the Institute of Physics Publishing, but with the Institute of Physics Publishing, IOPP, all their profits of margin goes back into surplus, goes back into the Institute of Physics to support physicists. But here's George Monbiot, never want to mince his words, with the classic title, Academic Publishers Make Murdoch Look Like a Socialist. I love that. And why is that? Well, taxpayer funds us to do research, we publish, and then the taxpayer has got to pay exorbitant prices to actually access. How many times have you been off campus and you go to try and get a paper and it's like, oh, that'll be $119.99, please. 10% of at least in the last round, I don't know what it is, so that's slacking me. I need to find out what it is for this round. But 10% of the quality-related funding, the HEFGI, or what used to be HEFGI devolved funding, is spent on journal subscriptions. So we go through the pain of the ref, and 10% of that funding is effectively spent on journal subscriptions. So the publishing industry has a huge vested interest in ref. So the particle physicists and the astronomers, I don't know how many of you have heard of something called the archive, where you put up preprints of your papers. In condensed matter physics, my area, it's not used as much, but it's certainly increasingly used. Chemistry and biology is really not used at all. But the particle physicists and the astronomers use it all the time, and they put their papers up there, and the papers are cited there, and indeed, in some forums, the papers are discussed long before publication. The archive is roughly $400K per annum for thousands of papers to maintain that. So, as I say, compare with about 100 million in journal subs. I don't know if many of you are familiar with this cost of knowledge boycott. A guy called Tim Gowers, a mathematician, put it up at 15,000. I think it's something like 16,000 now signed up to this. Elsevier and Springer, as well as a number of other commercial publishers, all exploit our volunteer labour. Huge public subsidy. Because who does the referee and who does the editing for free? Huge public subsidy. I really laughed when one of the academic publishers said, well, we're one of the few industries that don't receive any direct subsidy from the government. Yeah, you don't receive any direct subsidy, but your subsidy is coming directly from the work of academics. Right. This is gobsmacking. Phil Campbell, who actually used to be the editor of Physics World and somebody I have a huge amount of time for, editor-in-chief of Nature, estimates his journal internal costs at 20K to 30K per paper. How? Just how can it be 20K or 30K per paper? And even when you look at some of the estimates that are out there by publishers and those who are familiar with the publishing industry, the best, even exaggerating some of the costs, is about 3K. And let's just put this as a nice, let's look at the operating profits for the different industries. And right up there with 34, 36, 40% scholarly publishing. Right, so killer question. Now I'm getting to the end. These are going to be the last couple of slides. Why don't we just publish everything in open access journals? Why don't we put it on the archive? Well, it comes right back to what I said right at the start. We pay for the brand. That's what we pay for. We pay for the stamp that says that this is a quality paper, regardless of whether it's a quality paper, because we don't put enough effort, because we don't, to be fair, have the time, or we don't make the time to put enough effort into judging these. You know, I heard yesterday that at a university very close to Nottingham, the most recent round of lectureships they've announced, they've had something like 400 applications. How do you sift those? How do you compare those, etc.? One thing you should not do, however, is just rely on the brand. At some level, those papers have to be read. And I'm going to really, I love to flag up this. This is particularly Stephen Curry, who's in the UK, very prominent in terms of science funding policy, getting involved. He's been very heavily involved with the group, along with somebody called Jenny Rohn, called Science is Vital, who've merely made the case for science funding, etc. This is a classic blog post. Just if you take nothing away from my talk, my ranting today, look, Google "sick of impact factors" Stephen Curry, where he talks about the statistical illiteracy of impact factors and just the pure nonsense. Lots on his blog, Reciprocal Space, about impact factors. We have to change how we assess academic researchers. That's the key thing. The nonsense of a H index, it just is really. I hate to use this quote, and it's probably apocryphal, like so many of Einstein's quotes. But there is this: what counts cannot always be counted, and what can be counted not always counts. And I'm a physicist. I spend my time trying to be objective and quantitative, but you've just got to accept that some things you cannot reduce to a number. So we have a number of these papers. This is a really good one from Vila, 2012, in terms of evaluating how we evaluate. And I'll leave you with this. This is my final slide. I'm a big Douglas Adams fan. Flaws in the literature are not someone else's problem. For those of you who are familiar with the likes of universes and everything, there's somebody else's problem field, which is like an invisibility cloak. You put this someone else's problem field generator on and you just ignore it. It's there, but you ignore it because it's somebody else's problem. And that we consistently got that message. Why are you doing this? Haven't you got better things to do with your time? Isn't it just a bit unseemly and a bit rude, just not cricket, to be criticizing other groups' work like this? We have to get beyond that for the reasons I said in terms of taxpayers' money, for one thing. Thank you for listening to me rant. Very happy to take questions. That makes a change.
We've got 15 minutes now for questions, so please.
I'll sit down if that's okay. Yes?
Thanks very much for a great talk. Yeah, if I could just add one other sort of possible explanation in there, that's how we fund science. So they're competitive grant allocation. So this often means that you get hundreds of applications, submissions, and they're all very hyper-specialised, basically. There's only maybe 10 people on the committees. So then judgment is devolved to impact factor or the branding or this kind of thing. And then that seems to have a knock-on effect at the faculty level, because you need to hire people who are self-standing. And then, so you need to hire people that can bring...
And it goes round in a circle.
And then, yeah, that's going to be the people with the higher impact CV.
Yeah.
So how we fund science is a really fundamental question.
Absolutely. No, it's with regard to the funding of grants, impact can play out in two different ways. There is impact factor, as you mentioned, and this nonsense of looking at the journal, using the journal brand name. What's very interesting in physics, at least, most of those grants, when they're reviewed, they come back, they're sixes. They're really heavy. The science is great here. And so the Research Council argument has always been that, well, impact's a secondary criterion in terms of pathways to impact and national importance. It's what comes first is the scientific quality. But for physics, at least, and I can only speak about physics, the vast majority of those grants are rated very highly in terms of the science. So what is nominally a secondary criterion becomes a de facto primary criterion. And so what makes a big difference is the management case the pathways to impact case and the national importance case. Because the science, you know, the referees have agreed the science is great, so how do you decide? And so impact, the other type of impact in that case, not impact factor, but impact in general plays a big role there. But yeah, it's a question of time. We don't have time to assess these things correctly. That's the problem. And indeed, we don't often have the right blend of expertise to assess these things correctly. So the two very interesting. So thank you for that question, great question. First of all, there's a very strong cultural difference between physics and engineering, whereby we, for example, for the last ref, and very many physics departments were told this, do not waste your time on conference proceedings. Get peer-reviewed papers into the primary literature, not conference proceedings, because they fall, you know, they're just not given as much kudos. Yeah, but even peer-reviewed. So I guess primary literature isn't probably the right word, but journals like the journals I've been talking about, rather than conference proceedings. That's a big cultural change, I know that. And also computer science, for example, is another one where conferences. For physics, it's not so much the case. So that's the thing. But in terms of, did this come up with conferences? It came up at the level of over coffee breaks, you know, there's something very wrong with these data. Was it immediately challenged? No. There is an issue of putting head above parapet, I think, in some cases. But certainly there was an undercurrent of there's something wrong with this, but do we need to waste time on it? Or should we waste time on it? So very good question.
With the publishing companies now moving into, you know, the hottest researcher and so on, Elsevier and all of that are doing this. I mean, I can just see that there's a kind of ratcheting up of the stakes actually. And it seems it's almost a bit more endemic in the sciences. And is it partly the genre, not something like Nature, that's kind of it's a science magazine, but it's actually selling lots of copy. I mean, it's talking about the genre of that.
You might be able to correct me, but I heard recently, I haven't checked up, but I heard that the majority of Nature subscriptions come not from libraries, which I thought, and academic institutions, but actually from personal subscriptions. So in that case, it is this blend of you know, a journal and a magazine, which is why the newsworthiness is so important. So it's, in that sense, it's almost a bit like Scientific American or New Scientist, but it's got, you know, important papers in there, important scientific results. So that's a very interesting question. There is the culture of, you know, the scientific superstar, of course, and that's, you know, that's what they're trying to tag into, absolutely. And it's dangerous. It really is dangerous.
Well, but to reinforce your point, I think that is broader than just that sort of magazine feel to it. A few years back, the American Political Science Review, which is the leading journal in U.S. political science, published an article exploring the sort of separated twin studies of political ideology, and concluded that there was a genetic component to individual ideology from that. That has since been come in for quite a lot of criticism, but it was the first article of not just of the issue, but of the volume, and very much got, you know, a lot of play in the media, a lot of play from the association as well. So I suspect that it's not, you know, certainly the magazine kind of format pushes in that direction, but even with a very traditional, what is ordinarily regarded as very dry journal,
yeah.
You know, we're seeing that kind of thing as well.
Yeah. So and also we talked about altmetrics yesterday. You know, there's a huge clickbait aspect of this as well. Do you want a dry title, you know, really academic title, or do you want something that's going to get lots of throughput to the journal websites?
So is this, I mean, will it become so much more commercial like that? I mean, even publishing bad science is good.
For the journal, yeah. No publicity is bad publicity.
Take a risk, you know, because actually it's in the public kind of eye.
Yeah. So I was very naive for quite some time, and this has opened my eyes to it. I used to think that, you know, journal editors really were, you know, quite objective and tried to do the best in terms of having a fair balance. I honestly think there are cases where, oh, this is such a good story, we have to think about how we're going to choose the referees. We need referees that are going to be on side. I honestly think that's happening. I'd love to have direct evidence of that, but I suspect that for certain journals, they really choose carefully in terms of, well, we know these people are quite critical, we know these people are quite supportive, we really want to get behind this, so let's choose the supportive referees. Allegedly. To be fair to Nature, the quality of the reviews and the amount of time people spend on reviews for Nature, including myself, is higher, I would argue. And papers get a much difficult time. So the quality of peer reviewing, I would argue, is higher. But the stumbling block is not so much that. The stumbling block is getting past the editor in the first place. And again, I don't want to slag them off without, any sort of proviso or qualifier. There is some brilliant stuff, Nobel Prize winning, important stuff published in those journals. And interestingly, it's sort of a self-fulfilling sort of aspect of this, in that if the community feels those are the best journals, then they'll hold off publishing, not in all cases, but in some cases, they'll hold off submitting papers that they think are of lower quality. So in that case, it's like a psychological sift. But that's not to say there aren't problems.
Yes, I fully agree with your criticism of using the ACE index and the impact factors when we assess the quality of work, of course. But what do we do when we are in a committee and we have 100 applicants and they have like 20 or 30?
We go out to external referees, and we rely on those external referees, and if it takes more time, if it takes 10, if we have to get 8 or 10 opinions on this piece, then we do that. And we say it's going to take longer. We explain to the candidates it's going to take longer, rather than publish Nature Science, good, didn't publish in Nature Science, bad. I would much rather have the time and effort spent on that than using the brand name as a journal.
It's a lot of work.
It is a lot of work, yeah, but we're talking about people's careers.
Yeah, but I remember reading the memoirs of a Nobel literate, and he said that he sometimes used up to a year when he was in an assessment committee in the 1950s or 60s.
We can't go back to that, of course, but yeah, no, I'm not. There is a happy balance between that and between using a year or 2 years to consider, and just doing because it is too often this. It's like, oh, Dr. Smith's got really good publications. Yeah, they have. And you haven't read them. There's something wrong. There's something badly wrong in that. Lots of things badly wrong in that. Okay.
Other questions?
Okay, yeah.
If I could go back to that point you made in the middle about reproducibility of experiments and organised skepticism.
Yeah.
So, I mean, I know there's a few journals coming up here and there, like journal with negative results and so forth, but I don't know what the impact factors like for that journal. So whether you can have a career out of publishing.
Oh, I don't know about having a career out of publishing, but certainly having a forum where you can publish those results is a great thing, because they're so important to the community and they save so much time and effort.
Yeah. My question would be, so does science not live up to that standard of organised skepticism kind of across the board?
No.
You can't actually.
No, at the moment it doesn't. So I do this 4th-year course, which is about sort of this 4th-year undergraduate course, which is about sort of the sociology of science, about politics and philosophy and a number of things. And I kick off with Feynman's statement. Feynman was asked to define science. Feynman's statement, Richard Feynman, was science is the belief in the ignorance of experts. And for physicists, we all get a lovely warm glow about that. Yeah, that's right. We're so skeptical. We're so cynical. It's not like that at all. It really isn't. And it's exactly this stripy nanoparticle thing really brought back to me. Published in Nature Materials. Goes for the next review. Oh, they've published in Nature Materials. It must be good. We don't even have to read the work. It must be good. That's not organised skepticism. That's gullibility. So there are huge problems. Sorry to be the voice of woe. Though Labour won in Oldham, so it's not all bad.
In the social sciences, especially in the medical sciences, there's a big move towards the development of systematic reviews. I don't know if that pertains within physics.
Like meta-analysis or?
Yeah, like meta-analysis, but actually with a methodological focus. So it can be something as simple. The NHS Centre for Reviews Dissemination, for instance, at the University of York, will have a particular question, a
they then have a transparent process by which they search for papers that answer that question, and then subject them to very, very thorough kind of methodological critique. And we've done that in social sciences as well, and it's another kind of layer. I mean, it's quite telling. We did a study in trying to apply systematic reviews to studies of the impact of second homes on house prices in villages, I think it was, for which you would think would be a big evidence base. And indeed, we found, I think, about 190 papers, only of which about 3, I think, in the end, were methodologically robust to actually allow you to make some kind of inference. But it just seems to me to be another kind of institutional check on the science, as it were. So you actually have a systematic framework for which you pull together all the papers on, that particular aspect of nanotechnology, and you actually develop kind of methodological expertise, and you know that you'll be put through that.
So that's a really interesting point. So if you condense matter physics, and pretty well all of physics, I would argue, in terms of a review is like an overview of the literature. And people will write reviews, and sometimes those reviews are more critical than others, but not to the extent you're talking about. It's not.
This is about the reproducibility
Yeah.
of the review process, and actually being very clear about what the methodological criteria would be for the acceptance of having that as part of the evidence.
I'm trying to think of an example and I can't. The only way that works in science is, if there's a result that's published, others will try to reproduce it. If it isn't reproduced, then it's generally felt that there's an issue here, but that process can take years, if not decades.
Let me ask if there's 1 or 2 last questions. I'll just collect a couple if anyone still has anything. Maybe I'd ask you one question, if not just a more personal one. As you've become sort of more vocal about these things, I'm just wondering, do you find that there's changes in the way that editors approach you? Are you more or less approached for reviews? How are the colleagues?
Interestingly not. I'd like to be less approached for reviews. No, no, interestingly I haven't. And also in terms of criticism of research councils, to be fair to Nottingham, and I can complain about lots of aspects of management in Nottingham, one thing they haven't done is been heavy-handed in terms of, toe the corporate brand, toe the party line, as it were. So no, that hasn't been an issue. Not that I can pick up on, at least. I may well be on the, blacklisted, and don't ask Moriarty for a review, but I don't know. Yeah. Not that I can detect.
Well,
Okay.
thank you for a terrific talk.
Thank you.